Section 10.8 is on page 636, Taylor and Maclaurin series. We start off by looking at a power series. We call that f of x. And suppose f of x looks like this power series right here. Again, I'm going to upload this PDF in Blackboard, so you really don't have to worry about rushing and copying that. So if I look at f of x, it's really a sub 0, again substituting 0 in there, a sub 1 to x minus a, and so on and so forth. And if I look at f prime, a derivative of this f, I would notice that f prime, this would become a 0, this would become just a sub 1, this would become 2, a sub 2, and the list goes on. If I take another derivative, so a second derivative, and you would notice that, okay, you would notice that the derivative, this would be 0, the derivative of this will be 2a1, the derivative of this will be 2 times 3a sub 3 to the power of 1, and the list goes on. And if I take one more derivative, I would notice that, again, the derivative of this is 0. The derivative of this, since that's an x, that's 2 times 3. The derivative of this will be 2 times 3 times 2, x to the 1. And it's right there. And now that we see this, what I'm going to do, I'm trying to figure out what this equals. Believe it or not, that turns out to be the challenging part. Now, if this is f of x, if f of x equal this, if I take f of a, that would simply be a sub 0, because if I let x equal a, this will be 0, this will be 0, and this will be 0. True? And if I take f prime of a, I'll get that to be a sub 1. That would be 0. That would be 0. By replacing x by a, I notice all of these be 0. And if I take f double prime at a, I'll notice this would be 0. This would be 0. All of these will be 0. That will only piece that will remain. And if I take f triple prime of a, I'll get that. That will be 0. That will be 0. So this is what I'm getting. I'm getting f of a. I'm getting f of a to be a sub 0. F prime of a will be a sub 1 times 1 if you like. F double prime of a will be 1 times 2 a sub 2. And f triple prime of a, that will be 1 times 2 times 3 a sub 3. If this list goes on, the nth derivative of a, and let's see how this works. When this is the third derivative, this is a cubed. When this is the second derivative, this is a squared. When this is the first derivative, this is a 1. When this would be the nth derivative, this would be a sub n. Not only that, I notice if this is the third derivative, that's 3 times 2 times 1, which is 3 factorial. When I'm taking the second derivative, I'll notice this is 1 times 2, which is 2 factorial. When I'm looking at one first derivative, that's 1 factorial. So when I take the nth derivative, this would be n factorial. And if I want to know what a sub n is, remember that's really what I want. A sub n would simply be what? The nth derivative of a divided by n factorial. So now, if I go to the actual series and substitute a sub n in, my series would become f of x equal, well, let's see. A sub 0 is f of a. A sub 1 would be f prime of a times x minus a to the 1. A sub 2 would be f double prime of a times x minus 2 squared. F sub 3 or a sub 3 will be f triple prime of a times x minus a cubed, and the list goes on. And don't forget that a sub 1 right there, dividing by 1 is not a problem. That really doesn't mean much. But when I get to f sub 2 or a sub 2, that's really over 2 factorial. When I get to a sub 3, that's really the third derivative over 3 factorial, and the list goes on. And when I get to the nth derivative, or the nth term, a sub n, right there, that term, that would be the nth derivative of a divided by n factorial times x minus a to the n, and the list goes on. And that's really how it works. And if I look at the book, I would notice that in my definition, if I want to find a Taylor series centered about x equal a, I will get the series to be, and notice what they did. They replaced a by what we found right here. And there it is. And if I would like to center at 0, if I really wanted to center this at zeros, meaning if I let so wherever you see an a, you replace a 0, pretty much you will get the Maclaurin series, which is identical to Taylor, except I'm centering everything at 0. This might look like a lot of work, but guess what? This is it. And it's a bit simpler than you think. When they say find the Maclaurin series, they're saying center it at 0. And when they say find the Taylor series, they're saying center it at a. So what I need to do this, I need f evaluated at the value, the derivative, the second derivative, the nth derivative at this a, times these don't change. Those are the same. And if it's centered at 0, I want f of 0, f prime of 0, f double prime of 0, and all the way to f sub n of 0. Now, I'd like to look at some examples. I am going to go to the book. Oops, one page. There we go. And if I look at find the Maclaurin series on numbers 11 through 24, and this is on page 647. If I take problem number 12 for starters, I'm sorry, I meant to say this is page 640. So I want to find a Taylor, a Maclaurin. Since it's centered at 0, this will equal f of 0 plus f prime of 0 x to the 1 over 1 factorial plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial. Now, how many of those derivatives do you need? Well, as many until you get the pattern. The idea is for you to find the nth derivative and write a power series in general form. So I'll go on the side, and guess what? I know it's a bit confusing. This is f of x. So I'll go on the side, and what I need to figure out, only what those equal. Everything else is fixed. So f of x is actually x e to the x, and I'm gonna really, in this case, I'm gonna evaluate those at 0. That's a 0. F prime will be the product rule. And if I throw a 0 in, I'll get a 1. F double prime will be e to the x plus the product rule, e to the x plus x e to the x, which is 2 e to the x plus x e to the x. At 0, I have 2. F triple prime will be 2 e to the x plus e to the x plus x e to the x, the product rule. That's 3 e to the x plus x e to the x. That would be a 3, maybe one more. So far I see 0, 1, 2, 3. If I get a 4, I'm in good shape. That's 3 e to the x plus derivative of this, a product rule, e to the x plus x e to the x. That is 4 e to the x plus x e to the x. So it seems that this is going to be replaced by a 0, this is a 1, this is a 2, this is a 3, and this is a 4. Well, guess what? Then I could say x e to the x is roughly what? 0 plus 1 times x to the 1 over 1 factorial, 2 times x squared over 2 factorial, 3x cubed over 3 factorial, 4 x to the 4th over 4 factorial. Can you guess what this will be? Wouldn't that be 5x to the 5th over 5 factorial, and the list goes on? If I simplify, that's x to the 1 over 1 factorial. Wouldn't that be x squared over 1? Wouldn't that be x squared over x cubed over 3 factorial? And isn't this 4 times 3 times 2 times 1, those cancel out? Isn't that x to the 4th over 3 factorial? Plus, and I shouldn't put factorial there. Wouldn't that be 5 times 4 times 3 times 2 times 1? And that would be x to the 5th over 4 factorial. So if the series goes on, that's n equal to infinity. This is how I do the problem. I always start by tying everything to the power on x. If the power on x is an integer, that's n. If it's even, it's 2n. And if it's odd, it's 2n plus 1 or 2n minus 1. And I noticed, whatever this power is, this is 5, this is 4 factorial, this is 4, this is 3 factorial, 3, 2, and this is 1 less factorial. And where can I start? Do you notice the first power on x is a 1? So I could start at 1, and that would be my power series for x e to the x around 0. Okay,